Next, a situation. A layer of clay, 7.6 meters thick, is overlain by a deposit of sand, 15.2 meters thick to ground surface. When the water table is at the ground surface level, the saturated unit weight of the sand was determined to be 21.2 kilonewton per cubic meter, for which its dry unit weight is 18.2 kilonewton per cubic meter. The saturated unit weight of the clay is 18.8 kilonewton per cubic meter. When the groundwater table lowered by 7.6 meters, the degree of saturation of the sand above the water table was lowered to 20% at the mid-height of the clay layer. So question letter A, evaluate the effective pressure to kilopascal at the mid-height of the clay layer before lowering the water table. So here is the illustration. The sand is 15.2 meters in length, and the clay is 7.6 meters. And we are looking for the effective pressure at the mid-height of clay, which is at the center of it. That's 3.8 meters. So to calculate this, we need to use the effective pressure, that is total pressure, minus the pore water. So the total pressure is just the saturated unit weight of the soil times its height plus the saturated unit weight of the water times the height of water in the soil. So in this problem, we can use this simplified formula. We can use a summation is equal to, summation plus open parenthesis gamma sat minus gamma water close parenthesis times height. We can use this in two or more layers of soils that we are dealing with. For example, sand and clay. So we need to sum up. So the simplified formula for that is just y sat minus gamma water times the total height. When we use this if the soil is fully submerged. So let's solve. So for the effective pressure, first we gonna solve for the sand. The saturated unit weight of the sand is 21.2 kilonewton per cubic meter. That is subtracted by the gamma water, that is 9.81 kilonewton per cubic meter, times the height of the clay, that is 15.2 meters. Plus, we're gonna add the effective pressure for our clay, that is the saturated unit weight of the clay. It's 18.8 kilonewton per cubic meter minus the gamma water, which is 9.81 kilonewton per cubic meter, and the height, mid-height of clay is 3.8 meters. So we're gonna solve this. That is 21.2 minus 9.81 times the height, which is 15.2 plus 18.8 minus 9.81 times the height, that is 3.8 meters. And we can have an answer of 207.29 kilonewton per meter squared. That is 207.29 kilonewton per meter squared. Again, 1 kPa is equals to 1 kN per meter squared. So we can say that this is a kPa. So the answer for this question is letter B. That is 207.29 kPa.